In exercise 2D, we're going to bring in acceleration being gravity. So A is equal to G, which is equal to 9.8 meters per second squared. That's when it's going down, it's accelerating towards the ground. But if it's going up, acceleration is stopping its motion going up, so we'll be looking at minus G, or minus 9.8 meters per second squared. In this first example, a particle is projected vertically downwards, so it's going down, positive acceleration, from the top of a tower with speed u meters per second. It takes the particle 4 seconds to reach the bottom of the tower, and during the third second of motion, the particle travels 29.9 meters. Two parts: find the value of u and the height of the tower. So the information we're given here during this third second of motion, so between t is equal to 2 and t is equal to 3, the distance travelled is 29.9. So because acceleration is constant, we can say that 29.9, it must be travelling at 29.9 meters per second. So that's going to be my velocity. So the average speed over those seconds, 3 plus 2 being the average time here, divided by 2. So when t is equal to 2.5, we can say that the average speed is 29.9. So if we fill that into v is equal to u plus at, we may be able to find the value for u. So my 29.9, my velocity during that time interval, is going to be u plus 9.8 times 2.5. 19.6 plus 4.9 is 24.5. So that would leave u being 5.4 meters per second. So this average time interval is something we're going to see a lot of. Then we're asked to find the height of the tower. So what variables do we have? We have, well, we don't know the height of the tower. We call it s. We'll stick with our distance formula s. It takes 4 seconds to get to the bottom. U is 5.4. We have my acceleration under gravity of 9.8. That's enough information to use the s is equal to ut plus a half at squared. So the height of the tower is going to be 5.4 times 4 plus, now half a, we've seen this in projectiles, 4.9 by 4 squared. So s is going to be 21.6, and 16 5s are 90. 16 5s are not 90, they're 80. So take away 1.6, 78.4. These add up to a nice even 100 meters. So let's look at the questions now in exercise 2D. Question 1, a stone is thrown vertically upwards from ground level with an initial speed of 35 meters per second. So like a projectile, it's going up and coming down. So we have a max height. We have 2 points at which this stone is on the ground. So if we could, after how long will the stone hit the ground? So we're looking for time in the first part. So we can say that the displacement is equal to 0 when it's on the ground. So we should get two values here. S is equal to ut plus a half at squared. So s is equal to my initial speed, 35 times t, and it's going to be minus 4.9 t squared because it's slowing down as it goes up. Minus 4.9 t squared, that's equal to 0, and we take t out. We can factorize 35 minus 4.9 t equals 0, so t is equal to 0, my initial time, and t is equal to 35 over 4.9, that's 350 over 49, 50 over 7, I don't think it simplifies down any better than that. 50 over 7 is the point at which it comes back down to the ground. The greatest height in part 2. You guys have done projectiles at this point, so these questions will be easy for you. The greatest point, velocity is equal to 0. So we can say v is equal to u plus at. My velocity, which is 0, I'll change it to a 0 now. 0 is equal to 35 minus 9.8 t. So we can get the time taken to get there and use our displacement to get the distance that's travelled. So t is equal to 35 over 9.8, which is equal to 350 over 98, which is, divide 7 in, 50 over 14, which is 25 over 7, or just use a calculator. So 25 over 7 seconds. So my displacement is equal to ut plus a half at squared. I have my s is going to be 35 times 25 over 7 plus 1 over 2, and it's going to be obviously minus 9.8 by 25 over 7 to be squared. What will that give me? The first one's going to give me 525's 125, and then I'm going to have a minus. I have a 14 on the bottom and a 9.8 on top. I actually have a 49 on the bottom. I have 7 squared is 49 by 2. This one by this one squared is going to be 98, and if I divide minus, that's going to be 0.1, so I'm getting 10%. That's going to give me 0.1 of 625 25 squared, which is going to be 62.5, or just use a calculator. It's going to be a little bit easier. So 62.5 meters is going to be the greatest height. Question 2. A stone is projected vertically upwards from ground level with initial speed u. After 1 second, with t is equal to 1, it reaches a height of 16.1. S is 16.1. Find u. We should be able to equal s is equal to ut plus a half at squared, because if we have a now in all these questions, it's 4.9, or 9.8, half a is 4.9. So 16.1 is equal to u times 1 minus 4.9 by 1 squared. So 16.1 plus 4.9 is equal to u. So u in this case is going to be 21 meters per second. Greatest height, we know from all these diagrams, little tiny crap diagram here, v is equal to 0. So v is equal to u plus at. This will help me get the time. 0 is equal to 21 minus 4.9 by t. So t is equal to 21 over 4.9, which is 210 over 49, which is 30 over 7. So be careful not to mix up your formulas. Just let me do a quick reverse here. I was thinking so used to doing a half a. This is actually v is equal to minus 9.8 times t. So t is equal to 21 over 9.8. 21 to 10 over 98, which is 30 over 14, which is 15 over 7. So my displacement at t equals 15 over 7, s is equal to u t, and here's my minus half a minus 4.9 by 15 over 7 to be squared. Just type it into a calculator if you have one. In the old days, what did they do before they had calculators? I don't know. 45 minus, we have 49 on the bottom, 7 squared, and we have 4.9 on top, so that's going to give me 0.1 or 10% of 15 squared, 225, 22.5. So s is going to be the greatest height of 22.5 meters. Part 3, the time spent in the air before it hits the ground. Well, we know that s of y is equal to 0 when it hits the ground, so ut plus a half at squared equals 0. So I have 21t minus 4.9 t squared is equal to 0. Factor out my t, I get 21 minus 4.9 t equals 0. So my initial time equals 0, or t is equal to 21 over 4.9, which is 210 over 49, which is 30 over 7. And that can't simplify any further, so 30 over 7 seconds, or give it as a decimal if they ask you to. So that's question 2. Question 3. A particle falls freely under gravity from rest at a point P, so it's going down in this direction. After it has fallen for 1 second, so that's t minus 1 for that second particle, another particle is projected downwards with speed 14.7. And the first one was at rest, so I have u is equal to 0. Find the time at which they collide. Okay, well let's say, I'll change my R here, let's say they collide here. So the distances travelled by each will have to be the same. So I'll call them A and B. Okay, so A, the distance travelled, is equal to, so S, the big S, ut, so 0 times t plus a half at squared, which is minus 4.9 t squared. So that's the distance travelled by A. Putting in my minus, and I shouldn't, it's plus, it's travelling downwards. Just maybe do your arrow at the beginning. Obviously we couldn't have a negative distance there with t equal to 1. And then the distance travelled by B is going to be u 14.7 by t minus 1, it's after 1 second, and plus 4.9 by t minus 1 squared. So we'd have to let these equal each other. So 4.9 t squared, and people shouting in the background, is equal to 14.7 t minus 14.7 plus 4.9. So we're going to get t squared cancelling here. T squared minus 2t plus 1. So 4.9 t squared is equal to 14.7 t minus 14.7 plus 4.9 t squared. Cancel them. And then minus 9.8 t plus 4.9. Okay, do we have... Let me see here, 14.7 t minus 9.8 t. It's just going to give me 4.9 t, and that's equal to, it's going to be 14.7 minus 9.8. Sorry, 14.7 minus 4.9, which is thinking that the answer is 9.8. So t is going to be 2 in this case. Part 2, how far below P did they collide? Well, we can use either of the distances, we'll get the same answer. T is equal to 2. So for part 2, we're just going to get 4.9 by 2 squared. And 4.9s is going to give me that common number, 19.6 meters. And showing the motion of both particles on a speed time graph. So they're not looking for anything too complicated here. So if we take my first particle, it's traveling from 0. We're going to do it upside down here, it's going in that way. After 1 second, the other particle is coming by with a velocity of 14.7. That's my speed and my time. So it's starting from this point and it's going along in this direction, something like this. So that's all they're looking for there. Question 4, a particle P is projected upwards from the ground with an initial speed of 47 meters per second. 2 seconds later, a second particle Q, so T minus 2 for Q, from the same point with velocity 64.6. How long is Q in motion before it collides with P? Okay, well, we're going to have to find, let these distances equal each other. They're going to collide. S1 is equal to S2. So let's look at P. And we're using S is equal to UT plus a half AT squared, obviously. So for P, speed is 47 times T. We're going to have minus, it's going up this time, so minus 4.9 T squared. So that will be equal to Q, which is 64.6 t, ut minus 4.9 by t minus 2 to be squared. Okay, so we're going to get 47t minus 4.9t squared is equal to 64.6t minus 128, 129.2 minus 4.9 by t squared minus 4t plus 4. 47t minus 4.9t squared equals 64.6t minus 129.2 minus 4.9t squared. They cancel. Plus 19.6 minus 19.6t minus 19.6. So tidying up my t's, I have 64.6 plus 19.6 is going to be 84.2. I'm going to have to bring that 47 across, minus 47. And that's going to be equal to, bringing the numbers to the left will make them positive, 129.2 and minus 19.6. So we're going to add them together to get 148.8. So that's going to leave me with 37.2. T is 148.8. I think that goes in 4 times. 430 is 120, 28 is 148 and 0.8. So T is equal to 4. I'll just check the question here. How long will Q be in motion before it collides with P? Now Q is the second particle, which is T minus 2. So therefore Q, 2 seconds in motion. The height at which the collision occurs. So the height at which the collision occurs, well, S is equal to UT. So 64.6 by 2 minus 4.9 by 2 squared. So that's going to be 129.2 minus 19.6, which is going to give me 109.6 meters, the height at which the collision occurs. Question 5. A stone projected vertically upwards with initial speed u rises 70 in the first t seconds. So we have u equals u. S is equal to 70 and t is equal to t. So we also have A is equal to minus 9.8 in this case. Then we have a second piece of information, another 50 meters in the next t seconds. So u is equal to u. S is 70 plus 50. T is equal to t. But t is not equal to t. T is equal to t plus t, 2t in the next t and t seconds. And A is also equal to minus 9.8. So we can see here we have two unknowns, u and t, which is what we're asked to find. So like a lot of these questions, we're going to form two equations with our unknowns being u and t, and then we're going to solve them. So let's look at S1 here and S2. Or S is equal to ut plus a half at squared. So for S1, the first part of the question, we're going to get ut minus 4.9 t squared is equal to 70. And I don't think we can tidy that up anymore yet. Okay, S2 is equal to u by 2t minus 4.9 t squared, and that's going to be equal to 120. Just tidy it up so you can see it, 120. Okay, so we have 2ut minus 4.9 t squared is equal to 120. Just getting distracted here. 4.9 by 2t to be squared. So that's 4.9 by 4t squared. So it's going to give me 2ut minus 19.6 t squared is equal to 120. So if I bring this one down and multiply it by a minus 2, I'm going to get minus 2ut plus 9.8t squared is equal to minus 140. So I can solve down for t now. I'm going to just change both the positives. I could get minus 9.8t squared is equal to minus 20, but 9.8t squared is going to be equal to 20. Does that work out evenly for me? Let me get rid of the decimal. 98t squared is equal to 200. So t squared is equal to 200 over 98. We can see where it's going now. T squared is going to be 100 over 49. They normally work out these questions. So t is going to be equal to the square root of both 10 over 7 seconds. So u, I have ut minus 4.9 t squared equals 70. So I'm going to get u. So therefore we get u by 10 over 7 minus 4.9 by, I'll square it straight away, 100 over 49 equals 70. So I'm going to get 10u over 7 minus, that's going to give me a 0.1, so it's just going to leave 10% of 100, which is 10, equals 70. So 10u over 7 is equal to 80. 10u is equal to 560. So u is equal to 56 meters per second. Question 6. A stone thrown vertically upwards under gravity with a speed of u, a, from a point 30 meters above the horizontal ground, and the stone hits the ground 5 seconds later. Okay, well, let's just have a look here. The stone's being thrown from here. It's going to hit the ground here. So we can say here my displacement in y is going to be minus 30. So just be careful with these when they're not exactly on the horizontal ground. So I have s is equal to minus 30. U is equal to u. A is equal to minus 9.8. It's thrown vertically up, so it's negative, and t is equal to 5. So we should be able to fill this information into s is equal to ut plus a half at squared. We only have one unknown. So minus 30 is equal to 5u minus 4.9 by 25. So minus 30 is equal to 5u minus, well, 25 is 125. Take away 2.5, 2.5. 5u is going to be equal to that minus 30 on the other side. 92.5. So u is going to be equal to 18.5. 20, take away 2, 7.1.5, 18.5 meters per second is u. The speed at which the stone hits the ground, well, speed is velocity, v is equal to u plus at. We're looking for the speed. Initial speed is 18.5. A is minus 9.8. And t is 5. So we're going to get v is equal to 18.5 minus, that's going to give me 49. So v is going to be equal to 30.5 minus 30.5. So we're going to call that 30.5 meters per second for the speed. Question 7. A particle is projected vertically upwards from ground level with velocity 49 meters per second. Little diagram here. Don't need this bit. So the height's 2 times when the height is 78.4. Prove t1 plus t2 is equal to 10. Okay, well we can say displacement is equal to 78.4. U is equal to 49. We need to find t. T is equal to t A is equal to minus 9.8. So we have S, U, and A, so we can find T quite easily. S is equal to UT plus a half AT squared. 78.4 is equal to 49T minus 4.9T squared. So we need to factorize this. 4.9T squared minus 49T, and that would be plus 78.4 to give me two positive T's equals naught. 49T squared minus 490T plus 784 is equal to naught. Does 49 go into 784? Well, it goes into 490. And 490 to 784 is 294, which is 6 of them, 240 and 54, 6 of them. So it's going to be T squared minus 10T. And 10 and 6 is 16 of them go in there. So we have T minus 8 by T minus 2 is equal to naught. So my times are 8 and 2, T1 plus T2, 8 plus 2, which is 10, which we were asked to show. Okay, final question in this section. Question 8. A particle is projected vertically upwards from ground level with velocity 70 meters per second. It is at a height 210 meters above the ground, obviously at 2 times, T1 and T2. And just prove this, so sometimes we just get T1 and T2 and multiply them by 7, the product of them. So we can say U is equal to 70, write down our variables. A is equal to minus 9.8, T is equal to T, and S is equal to 210. So S is equal to UT plus a half AT squared. 210 is equal to 70T minus 4.9 T squared. 4.9 T squared minus 70T plus 210 equals 0. 49T squared minus 700T plus 2100 equals naught. 7T squared minus 100T plus 300 equals naught. 7T by T has to be, looks like 30 by 10, and it is 30, and 70 gives me my 100. So T is equal to 30 over 7, or 10. We'll call this T1 and T2. 7 T1 T2 is equal to 7 by 30 over 7 by 10, which is equal to 300. Hopefully that's what we were asked to show, and thankfully that's what we were asked to show. So that's the end of exercise 2D. So dealing with letters instead of numbers in 2E is a little bit trickier, but follow the same procedures each time and you should be able to master this topic.